With only 20% of the ocean floor being mapped, there's a lot of mystery held within. Naturally, humans tend to stay away from the unknown, but us scholars are here to counteract that stagnant mindset. So let's dive in. This is a side profile of the depth layers in the ocean. Today we are focusing on the extremes, just the epipelagic and hadalpelagic zones. But what could possibly be so different about the top and bottom of the ocean? The first difference is light. The epipelagic zone extends 200 meters deep and is the only zone in the ocean that contains enough light to have photosynthesis occur. It is called the photic zone. And our land environment needs light too. None of this would be here without light. Past 200 meters, the water is so dark that no plant life can survive there. This is called the aphotic zone. The ecosystem is nothing like we know. It is darker than this paper. And darker than this room. That's pretty dark. The Hadal zone is clearly aphotic, as it extends to the bottom of the deepest trench at 11,000 meters deep. This is a point called Challenger Deep. It is in Pacific Ocean's Mariana Trench. To give a visual, Mount Everest is 8,849 meters tall, and when placed in the ocean, it still doesn't reach the trench floor. Another main difference between the hadalpelagic and epipelagic zones is pressure. You've probably been in a pool before, just like little Timmy here. He starts at the surface, but the deeper he goes, the more pressure the water puts on him. In things like a 10-foot pool, you may get an ear pop. But the ocean is deep, and every 10 meters below sea level, it's an additional atmospheric pressure placed on your body. At 11,000 meters deep, there is over 1,000 atmospheric pressures on the ocean floor. A person will be crushed instantly. Poor Timmy. However, some species still thrive in these environments with special adaptations. This is an anglerfish. It is famous for the bioluminescent light hung by its mouth to attract prey. These are chemosynthetic bacteria. The fancy way to say they use minerals to create their own energy. They are similar to the producers in photic zones and vital to deep-water food chains. These are jellyfish, which are found in almost every layer of the ocean. Due to their simple designs, they are highly adaptable. Due to the more favorable environment in the epipelagic zone, this small layer holds 90% of all marine life. Here are 3 examples. The clownfish eats algae, which needs sunlight to grow. The sea turtle needs land to lay eggs on. The brain coral needs sunlight to grow, showing why these species live in the top ocean layer. As you can tell, each organism is suited to its unique environment, creating the perfectly intertwined ocean we know today. I'd like to give a big shout out to my marine ecology teacher, Mr. Harker, for teaching me all the information I know. But the links for sources are right here, and thank you for your consideration.